In the first tab, we will download the Arduino Uno schematic. Go to your favorite browser and search for Arduino Uno schematic. Scroll down and I will download this Arduino Uno revision 3 schematic. Download this schematic and open in any PDF viewer. So this is the Arduino Uno schematic, and next step is to set up a new project in our OrCad Capture CIS. So just go to the OrCad Capture CIS and we will set up a new project here. Now the first step in OrCad Capture CIS to set the design template. Just go to the option, click on design template, click on title block and fill your title block here. So our title is Arduino Uno. Our title is usually our project name. Next you can type your organization name. I type the Udemy here. Now you can type the address. Next, this is the document number 1, revision 1. And I will use the title block 2. Now click on page size. I'll use the page size C. And I leave everything as default. Now click OK. Now click on new project. Give your project name Arduino Uno. Next, browse the location. So I'll save my project in this folder. So make sure you select the folder. Now click OK. We don't want to use any simulation. Click next and click on finish. Now this is the OrCad Capture CIS environment and this is our project manager, and you can also close this start tab, right click, click on close, and in this schematic design this is the name of our project, and in this project we have one schematic and one page is attached here. So we will draw our schematic on this page. Now we will start with our schematic. Just go to the data sheet and find the biggest component here. So the biggest component is our microcontroller. So we will place the microcontroller first. Just go to the OrCad Capture CIS, hit the place part icon and search for ATmega 328. Now you can see we cannot find the component here by the name of ATmega. That means this component is not in our library. So we have to create the schematic symbol for this. But this will take a lot of time. So I will download the schematic symbol and footprint from SnapEDA. Just go to the Google and type SnapEDA. Open the first link and search here the part number. So in the schematic, the microcontroller part number is ATmega 328P. So I'll search for ATmega 328P. This is ATmega 328. Search for this. And we will use the DIP28 package. So just open this one. And this is the schematic symbol and this is the footprint. So I will download the schematic symbol and footprint both. So I will click on this link. I'll select my software. I have a OrCad Allegro V17. So you have to sign in for this. Now select OrCad Allegro. And this will download a zip file in your system. Now extract this file, create a new folder, ATmega 328, and copy all these files in this folder. Now we have a lot of files here. We have a DIL28 PSM. This is our footprint. This is our pad by the extension of pad file. And this is the configuration file of our schematic. Now go to your OrCad Capture CIS, click on File, Import, and select this EDIF. Now browse the location. So this is the folder ATmega 328. Click on this configuration file and now click OK. Now our schematic symbol is successfully imported. You can see 0 error and 0 warning, and this schematic symbol is stored in the same folder here. Now you can see we have a OrCad capture library file here, and we will open this library file in our OrCad software. Just go to the file, open, click on library, and in the same folder we have a library file here. Select this, open, and this is the component and in this library. So select this component. Now this is the schematic symbol for our ATmega 328. So all the pins are perfectly aligned. So we will save this symbol in our own library. Just go to your project Arduino Uno, click on File, New, and add a library here. Now library is added here. Just select this library, right click and click on this Save As, and we will save this library in the default library location. Just go to your C drive, installation folder of your OrCad Cadence SPB 17.2. Now click on Tools, Capture, and this is the library folder, and we will save our library here. Just give any name to your library. Now you can see this is the library path, and in this library we will copy this component from here. So just go to this ATmega 328 component here, right click and copy, and we will paste this symbol in our own library. Select the library, right click and paste it here. Now we can close this, and we successfully imported the schematic symbol for our ATmega 328. So click on this, and you can verify from here the component is successfully imported in our own library. Now we will do some minor adjustment. Select this reference designator, and we will give a name as U. This is a part reference prefix, that means your reference designator. Now the font size should be a little bit bigger, so I'll select the 7, and same for this name. The font size should be 6. Now right click and save this. You can close this now, and we will place this part in this page here. Now go to place part option, click on add library, and we will add our own library by the name of my library. This is my library. Click open, and this library has one component. Double click and we can place this component on this canvas. Now right click and mode. And in the same way we will import this ATmega 16U2 from SnapEDA. Now go to SnapEDA and search for our component. This is ATmega 16U2MU. Search this component. Now this time we will use the TQFP32 package. So verify the component from your data sheet. This is MUR, and we will select this one. This one is schematic, and this one is the footprint of the component. Click on download symbol and footprint. Select your tool, OrCad/Allegro. Now go to your download folder. This is the file. I will extract it here. Now I will create a new folder for this too. This is ATmega 16. I will copy all the files in this folder. Now go to your OrCad Capture CAS, click on File, Import, click on this EDIF, go to your ATmega 16U folder and click on this configuration file. Open and click on OK. Now click OK. Now go to File, Open, and library. The library file is created in the same folder here in this ATmega16U. Select this library file, open, and this is the component here. Double click it and we can see the component here. Now select on reference designator and change the font size. Select the font size 7, click on the name, change the font size to 6. Now right click, save, right click and close it. And we will copy this symbol to our library. So right click on the symbol, copy, and we will paste this symbol in our own library. Select the library, right click and paste it here. Now you can close this one, right click and close it. Go to your page, go to place part, and now you can see the one more component is added here. Just double click the component and we can place this on this canvas here. Now right click and end mode. Now we have successfully imported the components here. Now we will set some preferences. Just go to the option, preferences here, go to grid display and select this grid spacing to 1/2 pin to pin spacing. Next is pan and zoom and set the zoom factor as 1.2. Now click OK. Now go to your data sheet and next we will place these headers here. So go to place part, select all the libraries and search for header 10. Double click it, press R to rotate and place it here. Then press escape. Now search for header 6. Next is header 8. And we will place this reference designator close to the connector here, same as this name. Now go to your data sheet and from this data sheet you can see this port is start from PB0 to PB5, but in this symbol this start from PB5 to PB0, so we have to swap the pins. Select the component, right click, edit part. Now first delete all the boundaries. Select the boundary, delete it, select this one, delete. Now we will expand this rectangle. Now we will change all these pins. So pin 2 is at the bottom. Next is pin 3. Now same for port C. Now for port B. Now adjust the pin from left hand side. Reset pin on the top. Next is our crystal pins. Next we will place the VCC. Next is analog VCC. Analog reference here and the ground pin. Now we will place a boundary on this. Just go to the place, a rectangle, click on the first point and drag the rectangle to the other side. Now right click and close it, update all, yes. Now we can connect all these header with this microcontroller. Go to wire. Now next we will first finish all the components related to this ATmega 328. Just move the name to the bottom, go to datasheet, and now we will place the crystal across this crystal pins. Go to place part, type the crystal, double click it and place it here. Next, place the resistor. Place it here. Escape. Next, ceramic capacitor. Select this non-polar. Double click it and place it here. Now this resistor is 1 mega ohm. Just tap the value here. We will use the crystal of 16 megahertz. And these capacitors are 22 nanofarad. This one is also 22 nanofarad. Now move the names. Now connect these pins, go to wire. Next we will place the ground symbol here. Just go to this power connector here. Select the ground in the Capsium library, click OK and place it here. Right click and end mode, or you can press escape from your keyboard. Now go to your datasheet and next we will place the capacitor across these VCC pin. So we will also place one ferrite bead in order to stabilize this circuit. But in this schematic they only placed a 100 nanofarad capacitor, but we will also place a ferrite bead in order to stabilize this circuit. Just go to the OrCad capture, place this non-polar capacitor, escape, and next search for the bead. This is the symbol for ferrite bead and we will place it here. So this is 100 nanofarad. And we will use the ferrite bead for this. So we will type the name after when we search the component from DigiKey. So for now I will leave it as it is. Now copy the component, paste it for analog VCC also. Now go to wire, connect all these pins together. Now you can copy this ground symbol and paste it here. Now go to place power and select the VCC from Capsium library. Place it here. Change the name to 5 volt. Now copy and paste it here also. Now these are the decoupling capacitor, and these capacitors should be placed near to this microcontroller in PCB layout. Now go to your data sheet. Now if I talk about this A reference pin, so A reference pin is connected to this connector, and 100 nanofarad capacitor is also connected. Now we will place the 100 nanofarad capacitor here to this A reference pin. Go to place part, search for capacitor. Change the name to 100 nanofarad. Next we will copy the ground symbol and we will paste it here, and we will also place the ground symbol here too. Now go to wire and connect all these components. Now go to your data sheet, and next we will place the reset circuitry around this microcontroller. Now go to place part, search for diode. We will use the Schottky diode. Search for this Schottky diode, double click it and place it here. Next we will place the resistor to pull up this pin. Next we need a switch, so we will use the SW double pole single throw. Now we also need a 100 nanofarad debouncing capacitor. Just search for cap NP. Change the value to 10 kilo ohm. Now we will change the name of this Schottky diode when we set the part from DigiKey. Next switch is OK. And this is 100 nanofarad capacitor. Next we need a 5 volt power symbol. Just copy from here and paste it here. Next go to wire and connect this. First the pull-up resistor, and connect this Schottky diode parallel to this pull-up resistor. Now connect to 5 volt. Now we will connect this circuitry with this push button. First move the circuitry a little bit up here. And this capacitor we will place parallel to the switch here. Select the capacitor, rotate it. Connect this point to this pin here, and we will place a ground symbol here. Just copy the ground symbol and paste it here. Now this is our reset circuitry, and you can easily understand how this works. Now this circuit is almost completed, and now we will move on to our USB bridge. Just go to your datasheet here, and from this datasheet, first we will match all the pins. This port B start from PB0 to PB7, and this is slightly different, so we have to change this part. Select the part, right click, go to edit part, and we will arrange all these pins according to our schematic. So all the power pins to the left and all the ports pin are digital pins to the right. So these are power pins. I'll move to the left, and this digital pins according to the PD0 to PD7. Now go to your data sheet. Now we can see the 22, 23, 25, 26 and 5 pin are not connected, so we will move it here. So this is 22. I will move it here. Next is 23. Now we can delete this external pad pin because we don't want to use the component with the pad. So I'll simply delete this pin. First select the pin and hit the delete button from your keyboard, and we can successfully delete the pin. Now we will move all these pins to the left. Now go to your data sheet, and we have from pin 6 to pin 13 on the right side. That means the port D. This is the port D, and I will move to the bottom here. Now this is the port B. Select all the pins, and we will move to the right hand side. Just move it here. We have port P, PB0 to PB7. Now we will expand the boundary of this component. First delete the pre-existing boundary. Select the boundary, simply delete it. Now go to your data sheet, and we have a reset pin, the crystal pins. So this is our reset pin. These two are the crystal pins. This is our differential pair for our USB connector. Now I have rearranged all the pins according to our schematic, and now we will place the boundary. Just go to the place rectangle, and we will place a boundary across this component. Now go to symbol, close it, and update all. Yes. And we have updated our symbol. Now move this reference designated here and name of the component to the bottom of this symbol. Now we can copy and paste the circuitry for crystal from this component to this component here. So just copy this crystal circuitry here, Control C, Control V, and place it here. Now in the same way, we can also place the capacitor and ferrite bead for this component also. Just copy the circuitry, Control C, Control V, and place it here. We have a space, so first we have to move the component to the right. Now we can copy and paste this circuitry. Now move this AVCC pin down here, select the component, right click, edit part, move this pin down here, close it, update all, yes. And this pin is connected automatically. Now go to your data sheet and we will place the circuitry for this USB connector here. So we will place the header 4 as a USB connector. Edit this part. Now first pin is VCC. I'll give the name as VCC. Second pin is D negative. Third pin is D positive. Just change the name here as D positive. And the fourth pin is ground. And we can also make the pin name visible from here. Just select this one. Now right click, close it. And this is our USB connector. So just change the name to USB type B. Next on the data sheet, we will place the 22 ohm resistor. Just copy the resistor from here and paste it here. Change to 22R. This is 22 ohm resistor. Now go to our data sheet and next components are variable or resistor. These components are used to protect the circuitry from electrostatic discharge. Usually we use a variable or resistor. So just go to the place part and search for variable resistor. Just type the varistor here. And you can see the variable resistor here. Just double click it. Place it here. Now in the data sheet, the next component is 2.2 microhenry inductor here. So just search for inductor. Rotate the component and place it here. This is 2.2 microhenry. Next, copy the ground symbol from here. Paste it here. Now connect all these components. Now connect these variable resistor to each of these D negative and D positive pin. First I will connect to D negative and next variable resistor to D positive pin. Next connect this inductor to VCC pin. Now copy the ground symbol. Now the left part of this IC is almost completed. Now we will place the resistor and diode for this reset pin. Just copy and paste from here. Control C and paste it here. Go to datasheet. We will place the ICSP and this jumper header now. Go to place parts, search for header 6. Now search for header 4. Select the component, right click, edit part. Now move this first pin to the left hand side, second here, third to the left, fourth here, fifth to the left, and sixth to the right side. Now you can delete the boundary here. Delete everything, expand the boundary. Now we will place our own boundary. And similarly for this jumper. So this is our ICSP header. Go to datasheet. Now for this jumper, you can see the 21st pin will be connected to the 19th pin if we add a jumper here. So we will do the same. Just go to the wire. Connect 21st pin to the first pin of this jumper and second pin to the 19th pin. Go to datasheet, and next we will place this transmitter and receiver LEDs. Just go to the place part, search for resistor. Now search for LED. This resistor value should be 1 kilo ohm. And this will be our transmitter LED. Now make some space here for connection. I'll move this circuitry to the bottom. Now go to datasheet, check for the pin. This transmitter LED is connected to the 11th pin. So this is the 11th pin, and receiver LED is connected to the 10th pin. Now place a 5 volt power source. Now go to data sheet. Next is our transmitter and receiver pin for this IC. This is connected to pin number 8 and pin number 9 with 1 kilo ohm resistor. Just copy the resistor here. These wires I placed for net analysis. Now we will net analyze all the important nets. If you hover your mouse on the net, you can see the net name here, but we will give the specific names to all the important nets. This will also help in the layout process. If you go to your data sheet, so for this ATmega 328, these are the digital pins, so we will net analyze our circuit also. Just go to the place net analyze. First we will place the digital 0, press OK, and this is our digital 0. Click on the pin number PD0. So D0 is placed. Next place the D1, T2, digital 3, digital 4, digital 5, digital 6 and digital 7. Now these are the ADC pins. So just go to the net alias, just type the AD0, place your net alias here, AD0, AD1, AD2, AD3, AD4 and AD5. Now if you go to data sheet, these are the digital pin 8 and 9, net alias, D8, this is our digital 8 and digital 9th pin. Now go to net alias, next is our SS pin. Next is MUSI. Master out, slave in. Next is master in, slave out. And last is serial clock. Now go to data sheet. The 7th pin is ground, 8th pin is A reference, and 9th and 10th pin is connected to analog 4 and analog 5. Just place a wire here first. Now if you hover your mouse on the ground net, the name of the net is GND, so we can place the net alias as GND as a ground pin. Just place the ground here. Next is A reference. This is analog reference pin. Now we also have to place this A reference pin to this analog reference pin of the microcontroller. Just place the A reference here. Next we will place the AD4. Next is AD5. Now you can also verify the connectivity. Select the net, right click and go to select entire net. Then you can see these two nets are highlighted. That means these two nets are connected to each other. And similarly you can also verify for ground net. Now you can see all the ground nets are highlighted. That means this ground net is connected to all the ground nets. Now we will give a name to this reset pin also. Just type the reset, place it here. Now similarly to these VCC and analog VCC also, we will give a unique name to this. So I will type as 5V underscore VCC. Place it here, and for this will be 5V underscore AVCC. This net alias for this VCC pin is not compulsory, but it will help in the layout process. That's why we net aliases these VCC pins. Next we will place the power connector. Just go to the data sheet. This is the power connector. This is a header 8 and we will place in this on canvas here. Just go to place part, search for header 8. Place it here, escape, close it, zoom in. Now in schematic, the first pin is not connected, second and fifth pin is 5 volts, third pin is reset, and fourth pin is 3.3 volt. So just connect the 5 volt. So I'll copy the 5 volt from here. I will paste it here. Similarly, I'll copy the ground here. Now the second pin is VCC and fifth pin is also 5 volt or VCC. The third pin is reset to the main microcontroller. Fourth pin is 3.3 volt. Just type the reset, place it here. Now 6th and 7th pin. The 6th and 7th pin are ground and 8th pin is V input. So this is ground and this is V input. Type VIN, place it here. Now go to place power, search for VCC capsium, and we will place a new symbol for 3.3 volt here. Just rename to 3V3 and connect this to the connector. The first pin is unconnected, so I'll place the unconnected symbol here. Next we will place the 5 volt regulator to power all the circuits. Just go to the place part. First we will place the 12 volt DC jack. Just type the con space jack space PWR. This is the 12 volt power connector. Place it here. Next we need a diode. Place it here. Next component is 5 volt regulator. Just type LM7805 fixed 5 volt regulator, and we need one electrolytic capacitor and one non-polar capacitor. Change the name to 12 volt DC. This is 100 microfarad. The non-polar capacitor is 100 nanofarad. These are the standard capacitors, and the value of these capacitor you can easily find in the datasheet of 7805 in the recommended layout section. Next we will copy and paste the ground symbol. Now you can see the ground pin in this 7805 is invisible, so we have to make it visible. Select the component, right click, edit part, and this is the ground pin. Select the pin and click on this pin visible, and select the shape of the pin to line, and now you can see the pin is visible. Right click, close it, and update current. Now we will also copy and paste the input capacitor, and we will place the output. Now connect all these components. This diode is used to protect the circuit from reverse polarity. This pin 1 and pin 3 are ground. Now we will place the 5V power port here. Select the 5V symbol, copy and paste it here. Now this is the origin of 5V. From this point the 5V is distributed to all the components. Now you can see this is the V input net alias. So this is the V input connection here. So we will also net alias this. Just press OK and place it here. From here, cathode of the diode, this V input power goes to 8th pin of this power connector. Now also change the name of this to power. Now go to datasheet. Next we will place a low dropout 3.3 voltage regulator. This is not a normal linear regulator, but this is a low dropout voltage regulator. So just go to the snap EDS, search for LP2985. This is the schematic symbol. Either you can download the schematic symbol from here, but I will create at my own because this is a small symbol. So just go to the OrCad capture, just go to the place part, search for header 5. Place it here, close this, select the part, right click, go to edit part. Now we will edit this part. First delete all the boundaries. Now expand the boundary. This is the first pin. The first pin is our V input. Just type the name V input. Now the second pin is ground. Third pin is on off. Fifth pin is output. And fourth pin is bypass. Now make the pin name visible. Expand the boundary. Now place a rectangle. You can also change the type of pin. This is the output pin, so select the pin, and from here you can select as output. This is V input. From here we can select as input. This is also input pin. This is ground pin, so select the power, and this bypass pin is also input pin. Now right click, close it, update current. Now we will place the ceramic capacitor to the input and output. Just type the cap NP. Place it here and one capacitor on the output. Now if you go to the datasheet of this low dropout voltage regulator, then you can see the input capacitor is recommended as 1 microfarad. And this output capacitor is recommended as 2.2 microfarad ceramic capacitor. This is 3.3 voltage regulator and the name of regulator is LP2985. Next, give the input to this 3.3 voltage regulator. The input will be 5 volt and output will be 3.3 volt that we have used here. Now connect all the components. Copy the ground symbol. Paste it here. This pin is no connect. Place a no connect symbol. And connect ground to the global ground net. Now let's see what we have left with. Just go to the data sheet. We are left with the power selector circuit. So we need an operational amplifier and some resistors. Just to go to the OrCad Capture CS, go to place part and search for operational amplifier. Just type LM321. Double click it. Place it here. Now this is not the schematic symbol that we want to use, so we will edit this. Select the symbol, right click, go to edit part. Now the part that we are going to using in our project, the first pin is input. This is the input, the pin number is 1. This is positive input. The negative input will be pin number 3. The output pin is pin number 4, so simply I will delete this. I will change this to pin number 4. I will also delete these pins. Delete this. The pin number 5 will be our plus VCC. This will be the pin number 5 and this will be VCC, and pin number 2 will be our ground. So select this pin, change to pin number 2 and change the name to ground. You can also move this pin to here, delete this one. Now right click, close it and update all. Click yes. Now we will verify all the pins when we will assign the footprint to this component. Next we need some resistors. Just type the resistor. This will be 10 kilo ohm. Copy and paste it. We need one more resistor to make a voltage divider here. The output of this comparator will go to N channel MOSFET. Just type MOSFET. look for N-channel MOSFET. We have to make the pin number visible. For this MOSFET, right click, go to edit part. Now click on this pin number visible. The first pin is our gate. You can verify from here. The first pin is gate. The second pin is our drain and third pin is our source. Now right click, close it, update current. Now we will make some connections. This terminal will be connected to V input, so we will place a net alias here as a V input. Output is connected to the gate of the N-channel MOSFET. Now the negative input will be connected to the 3.3 volt. Place a net alias here. Just type the USB VCC. Click OK. We will place this on the source of this N-channel MOSFET, and on the output we will place 5 volt. Just copy the 5 volt port, paste it here. Also provide a power to the comparator. Control C, Control V. Now this circuit is a power selector. When we are using a 12 volt DC, then this circuit will switch off the USB VCC power. But if 12 volt DC is disconnected, then this circuit will switch on the power from USB VCC. Now we are almost done with our schematic except the power LED. So we will place the power LED now. Just go to the place part, type the resistor. Place your resistor here. Now select for LED. We will use a 1 kilo ohm resistor, and we will use the green LED as power LED. Now copy the ground symbol and paste it here. Similarly, we will also copy the 5 volt. Now we are done with our schematic. In the next step, we will rearrange all the schematic and we will annotate it. Now in this video we will arrange our schematic and we will annotate it. But if you go to the official schematic, then you can see this schematic is not properly organized and this schematic is not properly annotated. So it is difficult to find the components and it is also difficult to find the circuit flow. But we will annotate and we will rearrange all the components so that if you design your schematic and other people can also easily read your schematic. So first of all, we will rearrange all the components. Select the component and rearrange it. I will place all the power circuit to the left hand side and our microcontroller to the right hand side. Now move this. Move this power LED circuit. Move this power selector circuit. And now move this low dropout 3.3 volt voltage regulator. Now we will annotate our circuit. First we will annotate our main microcontroller. Our place, text, just type the main controller here, change the font size. I'll use the Times New Roman, and text size should be 22. Click OK. I will also change the color. I will go for this dark red. Click OK, and I will place the name here. Now in the same way, I'll place the annotation here. Place text. This is our USB bridge. Change the color to dark red and place it here. Similarly, we will place all the names here and we will rename it after. Now this is our ICSP, just double click it. ICSP, change the name. This is USB B, type B. USB connector, so I'll type the USB con. This is our power connector. Just type power here. This is 5-volt voltage regulator. This is our 3.3 volt regulator. This is our power selector circuit. And this is power LED. This is also ICSP. Now we can see our schematic is annotated and we will rearrange all the text. Now we can also place a differential pair symbol here. Just go to the place, select this ellipse, draw a ellipse here, and the same way draw a ellipse here too. End mode, and this is our differential pair. Place text. Change the font style to 18. Color to dark red. Click OK and place it here. You can also make it smaller. Now we are done with our schematic. In the next step, we will find the components from DigiKey and we will assign the footprints.
changes.
Life. Life.
I was fine when you held my hand. I was fine when you pulled me down. You said the stars would answer. You said our prayers were written down. I was fine when you pulled me in. We were forced to be human, and then the world came after, and I had never questioned it. And they said it was wrong. Started it all. was already shattered. Holding on to what we have and take us to the edge and back. Holding on to what we have and take us to the edge and back. This love that you never started, you once destroyed a broken heart that was already shattered. Holding on to what we have, you take us to the edge and back. Holding on to what we have, you take us to the edge and back.
changes.
Life. Life.
I was fine when you held my hand. I was fine when you pulled me down. You said the stars would answer. You said our prayers were written down. I was fine when you pulled me in. We were forced to be human, and then the world came after, and I had never questioned it. And they said it was wrong. We started it that you never started. You once destroyed a broken heart that was already shattered. Holding on to what we have and take a us to the edge and back, holding on to what we have. You take us to the edge and back. Yeah, this love that you never started, you once destroyed a broken heart that was already shattered. Holding on to what we have, you take us to the edge and back. Holding on to what we have, you take us to the edge and back. Yeah, yeah.